all formulas. And even in the final, I give you a whole sheet of formulas that, you know, I find it's not necessary to remember formulas. You're not going to remember them when you walk out of there when the course is done. But I want you to know how to use them. So I'll give you formulas, so that part of it is not so scary. The first part, you just had to take this and put this into your L1. Can everybody do this? Everybody can put this in their L1. Can you tell the difference between a population and a sample if they didn't exactly say it? Most of the time they use the word sample. From a sample of 24 things. From a population, they don't usually say the population. They use the word all, or they just say every or something. They just kind of have a way of saying it. Usually a sample will have some, and a lot of times they do use the word sample. So everybody knows the difference between my sample standard deviation and my population standard deviation. Which one is my population one? The first one. Looks like it has an O. Population standard deviation. This one's easy. It's my sample. It starts with an S. Okay, so make sure you know the difference. Can you find the variance once you found your standard deviation? Can you go to the word var in your calculator? Go to stat number 5. Click on your standard deviation and square it. Rule of thumb, round your standard deviation to whatever your mean is. It makes more sense if you're going to do a graph. Stop me if you have any questions, because the first couple are more like putting in your calculator, and I want to make sure everybody can do that. I didn't give you 27, no. 29. Can everybody make this chart? This is your plus or minus 1, your plus or minus 2, your plus or minus 3. Everybody can make this chart. Okay? So now, put your mean in the middle, add your standard deviations up, add your standard deviations down. You do have to know this. That plus or minus 1 standard deviation is 68% of your data. Plus or minus 2 standard deviations is 95% of your data. Remember, this is rounded. It's really 68.2, 95.2, but it's rounded. This empirical rule, the empirical rule is a little rounded, except for this part, because they don't want to say 100, because it's not 100. It never touches the end, so it never gets to 100. But we're going to consider your area under your curve to be 100%. Everybody can do this. Empirical rule. This you do have to know. Okay? So sometimes they'll ask between what two values do 99.7% of your data lie. Sometimes they'll say, give you a value and say from this value to this value, what percent of it is of your data. Either way, you lay that out. Sound okay? Stop me if you have any questions. Okay, 31. 31 is Chebyshev's rule. You're going to have one of these. Now, Chebyshev says this is not a normal curve. So either I will tell you it's not a normal curve, or I will tell you to use Chebyshev's. And on the test, I tell you to use Chebyshev's. This way, there's no confusion to say, oh, I didn't see that it wasn't a normal curve. Because 99% of the time in this class, we work off the normal curve. What you have to do, and it's not hard, and I'm going to give you the formula for that too, but the first thing you have to do is lay it out like it's a normal curve. And you have to find how many standard deviations above the mean or below the mean does this thing fall. So I lay this all out, 36, I keep adding 8. How many of them spend between 20 and 52? Between 20 and 52, what's my standard deviation away from the mean? 2. So therefore, K is 2. That's all you have to figure out. The rest goes into your formula. It's either going to be 75% or 88.9%. And then, if I ask you for what percent, that's your answer. If I ask you for how many customers were here, well, how many customers were there altogether? 40. So then you're just going to take 75 times 40. A lot of you forgot that part on the quiz. To take 75% of 40. Remember, if it's a decimal, you have to round, because we can't have a partial person. Just show me where your rounding is. Make sure I see your rounding. Because you are definitely getting one of those. 33. I gave you this one because you had to put it in your L1 and L2. So can everybody put this in their L1 and L2? Which one is the frequency, the L1 or the L2? L2. This is the number of televisions that households have. This is the number of households that have no televisions. 1 television, 2 televisions, 3 televisions. This book is already old. I'm sure all of your households are like my household. You have like 3 TVs, at least. So L1, L2, when you do your one-bear stat, make sure that it says your list is L1 and your frequency is L2. It can't be reversed. It has to be in that order. And this one, again, use the word sample in a random sample. Sometimes we would ask ourselves, is this all the TVs that we have? Is this all the households that we have? Nope, that's a sample. Sometimes you kind of have to just infer it. This one I like. This one is box and whisker, percentile. This one has everything here. So put this in your L1 and sort it. Let your table sort it. Can everybody do that? Put it in your L1 and sort it. You're going to put it in your L1. You're going to sort it. You're going to do a one-bear stat. And what are these guys called? Good. The 5 summary numbers. Good. That's what I need to make my box and whisker. Remember, it gets a title, right? It gets a title. It gets a number line underneath it. Not those values. Those are the values that you're going to pinpoint. Make the box around the middle 3, and then the whiskers. God bless you. Which of these quartiles would you say has the least variance in it? The third. Good. This is quartile 1, quartile 2, this is quartile 3, quartile 4. Good, Jillian. The closest together is quartile 3. It has the least amount of variance. If you laid out all your data and you separated it into quartiles, one of these days I'll get the new one and they won't have this problem anymore. So if you laid out all your data, here's my data. If you laid out your quartiles, quartile 3 is 54, quartile 3 is 54, one of those over there. I'm missing the other 2. So just lay out your quartiles. You have multiple numbers. So how do I figure out that? Just count. Count how many you have into each section. And then you'll figure out where your quartiles go. How many fall between the 3rd or 4th quartile? How many pieces of data were in this? What was the range of your data? Anybody, before I try to pull this back up? What was your max minus your min? 18. So your data is pretty close together. See why they're so close together? So you've got a lot of the same numbers repeating itself. How many actual pieces of data? What was your N? I know you didn't have to write it down. Did it say on the problem? If I pull this up, it'll take me like a half an hour to get it back down. 21 pieces of data. An easy way to do that, when you string out your data, let your calculator sort it. Let your calculator sort this. 21 has an odd number. So 21 means you're going to have 10 and 10, and then the guy in the middle, right? With me? So 10, 10. So count 10. 5, 6, 7, 8, 9, 10. These have 10. This guy is your median. So this technically is your quartile 2. This is your median. If I have 10, that means 5 and 5. My quartile 1 falls in between my 5th and my 6th. Are you with me on this? Because you're going to have to figure this out. 1, 2, 3, 4, 5. Your quartile 1 falls right here. And what was your quartile 1? 47.5. 47.5. See it? And then here too. Go 5. Here's your quartile 3. It says your quartile 3 sits at the 54. But my point in saying this is there's a heck of a lot of 54s here because your quartile 3 has the least amount of variance in it. Only goes this little bit amount, one position over. It's got a slew of 54s. It almost didn't have a box. So when you're looking for your quartiles, make sure you can count down. So how many occur beyond this? Count these down. Okay, and then a percentage over the whole. What did we say that? 21? So 16 or 17. If you choose 16, put 16. If you chose 17, put 17 so I could see it. This should have 5, 10, 11, and 16. It should be 16. Should be 16 down, and then 5 more give you 21. But if you put 17, and because you gave it to me here, that's not a big kicker because you're in the right area. All right? Can you all find that? That's important. Yes, Mrs. Moore? No, Mrs. Moore? Have the slightest idea what you're talking about? Hang in there, guys. I know you're all anxious for this week to be over. For the school week to be over, rather. Okay. This part is important, too, and I didn't give you this one. I gave you 45. Okay, I did give you 45. I'm going to ask you to do a graph, a sketch like this, and you have to do this anyway. Put your mean, count your standard deviations. Can everybody go up and down with their standard deviations? Yes, Nick? Okay. I'll give you this formula. This is your z-score formula. Now, make a placement with this. If my x value is 16,500 pounds, that's well above my mean. So my z-score is fairly high. I could almost find it on my chart, somewhere over here somewhere. So I know I'm between 1 and 2, very close to 2. Make sense out of this. Is my area to the left more than 50% or less than 50%? To the left. It's always area to the left. Because it goes from 0 to 100. So am I ranked pretty high if I'm at 16,500? Yeah, I'm pretty high up there, right? These are towing capacities. I'm a pretty good tower. I can come and tow anything that you need me to tow away because I'm pretty high ranked up here, right? So I would look this up in my z-score and I would see what percentile I am at. I can move big loads here. This guy, on the other hand, this guy can't move too many big loads. He's way down here somewhere, way down here. So when we calculate his z-score, he's a negative. And remember, -2, +2, it's unusual. He's heading towards the 3 almost. He's pretty unusual to have a towing capacity of that small, to have a truck. To spend your money on a truck and not be able to tow anything. Okay, so his ranking would be really, really small.
If it's between 1 and 2, what is it usual or unusual?
If it's between, you want your data to be between 1 and -1. This is where most of your data falls, the highest part of your curve. I would say as you go out to here, this is still fine. This is still good. That's the
after 1.5.
Yeah, I would say after that is pretty unusual. When you hit 2, it's unusual. Most of your data falls at the big chunk of the curve. Because don't forget, again, we exaggerate this curve. This curve really looks like this. It goes real narrow, and 2 and 3 are out here because those percentages are so small. And 1 is over here. Here's your 0, here's your 1, there's your -1. So these pieces are really small out here. We make it even because we need to write stuff in there and we need to exaggerate. Even your book says their curves will look more like this. You know, like ours does here. Where it's supposed to be really, really small at the edges. Yes.
So the answer could be not unusual
No, it's unusual because it's well past the truth.
for 1.97.
Oh no, for this one? No, this is normal. Yeah, I thought you meant that one over there. Yeah, no, this is a normal because you're within. You're about like you're under the 2. You want to stay under 2. I would still say normal. I'd say close to unusual. You know, close. Can we all look up on the table too? Can we find the z-scores on the table and give me the percentiles? Okay.
Want us to do that instead of doing the other thing?
Well, I'm going to ask you for the z-scores and then I'm going to ask you for 1 percentile. So in other words, if you look up the 1.97, you tell me where it is ranked of all the tow trucks. You just find me the percentile.
We don't have to do that for like particular thing. Like there's like 10 below, so it's whatever. Remember how you did something on the board that got completely different by what paper?
Oh yeah, no, don't do the z-score formula. The z-score formula is too exact. Your book is more like this part of it, where the z-score formula is a little bit more exact for this. We'll just look it up this way. Oh, that's the other one actually you wanted, the 16 over. That was for this one up here. When we went to z-scores on this one, I just want you to do this ratio, 16 over 21. If we do a z-score formula on this, it just was too exact for it. This is more just like rough estimate by the positions. Because having your standard deviation gives us a different look of it. And really, Box and Whistler doesn't really include your standard deviation at all. So we threw something in that really didn't work. I mean, it does. It is more exact, but your Box and Whistler doesn't take into account your standard deviation. So this one I want you to find that simple. Can everybody find that? Let's just count them out. I just want you to count. Count the middle of those, and count the middle of the other. So you got quartile 1, 2, and 3. It's that simple. All right, so tomorrow, yeah.
Coefficient of variation on the quiz.
Yes, coefficient of variation is there too. I will give you the formula for that. When you do a coefficient of variation, you're comparing how varied things are. Like you can't really compare men and women. So you see in that, who's a little bit more varied. Sure. Okay, thank you. Okay. So your coefficient, I'll give you this formula, but you only have 2 things to work with. You have a mean and a standard deviation. The mean is generally a lot more than the standard deviation. So if you divided it by this, that's 500%. That's not going to work. So smaller, divide by larger, multiply by 100. The one with the higher percentage has more variability. Okay? 107,